Hello everyone. Today we have to start this new chapter one, which is about chemical process diagrams. And in this chapter, we will mainly talk about how we can generate the different process diagrams. What are the different types of process diagrams, and what are the different conditions that we need to see while making these diagrams. Now, chemical process industry, it can be written as CPI. So, what is the role of the chemical process industry when multiple processes are integrated together to get the signal or multiple products that comes under the category of the chemical process industry? And what are the chemical engineers? The role of the chemical engineers is to produce those products at the economical cost and with the least amount of the energy. Now, what are the different types of chemical processes that you consider in the industry? There could be highly reactive system. You might have to deal with the toxic chemicals. There could be some chemicals that can cause corrosion in the system. So you have to be careful about the maintenance of those equipments. And what are the different operating conditions to operate different processes. Okay, so for each of the process, like if you're dealing with the reactor, then what is the recommended temperature and what is the pressure at which different reactants can be combined to get the products. And now, what are the errors and miscommunications and what they can cause? So, if you design any process and there is some error or any miscommunication, then the process can lead to explosion. So, these are some of the hazards. There could be an environmental damage, or there could be some health issues to the people that are working on the plant. Now, the most effective way of communicating information about a process is through the use of flow diagrams. So, whenever you go into the industry, the first thing that you learn there that you have to understand the process. What are the different equipments installed in that process, and how those equipments are being interacted with one another. So, you can get this information from the flow diagram. Now, let's see this example here, and it will give you an information about the different kinds of diagrams that we can actually make from any process. Let's see what we have here. The research and development group of ABC Chemicals Company, so this is the name of some company, worked out a way to produce alpha beta softol ABS. Process engineers assigned to work with the development group have pieced together a continuous process for making ABS in the commercial quantities and have tested key parts of it. This work involved hundreds of block flow diagrams, some more complex than the others. Based on information derived from these block flow diagrams, a decision was made to proceed with this process. So the first diagram that you make for any process, it is the block flow diagram. So you have to see the block flow diagrams of each of the process, and if different processes are integrated together, then you have to develop the block flow diagram of the whole process. Okay, so it can be one uh, uh, block flow diagram for any one process, or it can be a block flow diagram of the different processes that are being linked together. A process engineering team from ABC central office carries out the detailed process calculations, material balance, energy balance, equipment sizing, etc. Working with their drafting department, they produce a series of PFD, process flow diagrams for the process. As problems arise and are solved, the team may revise and redraw the process flow diagrams. Often the work requires several rounds of drawing, checking, and revising. Now, how you can differentiate between the block flow diagram and the process flow diagram? From the name you can see here, in the block flow diagrams there will be only blocks on the diagrams, okay? And these blocks will just contain the information about the temperature, pressure, maybe flow rates at the outlet streams of any particular process. But it will not include the key details of the equipment. So when it comes to the process flow diagram, it is the more advanced form of the block flow diagram. Now here you will see the actual shapes of the equipments that are going to be a part of your diagram. Maybe say you will see the shapes of the pumps, you will see the shapes of the compressor, maybe if there is some combustor, you will see the actual shapes and this kind of thing. Okay, so in the process flow diagrams, first thing that you will see, you will be having the actual shape of those equipments that are a part of the diagram. And apart from this information, you would be having an information about the material and the energy balance, what is the size of each of the equipment. So that will make the process flow diagram. So as we move from the block flow diagram to the process flow diagram, there will be an additional information on the material streams and the equipment sizing. Now, once you have this process flow diagram, we will move to the next diagram, that is the P&ID, piping and instrumentation diagram. Now, let's see what we have here. Now, the specialists in distillation, process control, kinetics and heat transfer are brought in to help the process team in key areas. Some are company employees and other are the consultants. Since ABC is only a moderate-sized company, it does not have sufficient staff to prepare the 120 P&IDs, piping and instrumentation diagrams needed for the new ABS plant. Now, with the name here, piping and instrumentation, this is the most advanced form of the flow diagram. Now in this piping and instrumentation diagram, you will see the actual shapes of the equipment that are being used. And apart from that one, you would be provided an information about the connection between those equipments, what is the length of that pipeline, the diameter of that pipeline, and what kind of instrumentation is installed on that equipment for controlling the process. Okay, so this is the most advanced form of this flow diagram that will show you the maximum information about the process. ABC hires a well-known engineering and construction company, A&C Company, DEF Corporation, to do this work for them. The company assigns two of the ABC process teams to work at DEF Corporation to coordinate the job. DEF Corporation process engineers, specialists, and drafting department prepare the P&IDs. They do much of the detailed engineering, pipe sizes, valve specifications, as well as the actual drawings. The job may take 2 to 6 months. Every drawing is reviewed by DEF Corporation's project team and by the ABC's team. If there are disagreements, the engineers and specialists from the companies must resolve them. Uh, Finally, all the PAFDs and the P&IDs are completed and approved. ABC can now go ahead with the construction and so on. Okay, so what we can see here, we can start with a simple block flow diagram with a very few information. Then we will switch to the process flow diagram with more information on the material and the energy balances, and then finally we move to the piping and the instrumentation diagram, which is the most advanced form of the flow diagram and contain the maximum information. Now as we study this chapter, we will also see some of the more differences between these three diagrams. Now let's see what are the stages of any project. So the first stage of any project is the engineering. So you have to provide the engineering design of any process. Then it will lead to the construction. Once you have that construction completed, then it will lead to the commissioning stage, then startup, and then the normal operation. Okay, and now during this operating period, many unforeseen changes are likely to take place. The quality of raw materials used by the plant may change. The product specification may be raised. Production rates may need to be increased. The equipment performance will decrease because of wear and tear. The development of new and the better catalysts will occur. The cost of utilities will change. New environmental regulations may be introduced, or improved equipment may appear in the market. Okay. As a result, plant operations must be modified and flow diagrams are updated accordingly. Okay, so these are the unforeseen circumstances that could happen, and your design should permit to incorporate these changes. Okay, so the engineering design that we make at the start of the project, it is just based on the input and the output information. Now, once the any design is approved and we make an actual plant, then maybe the specification of the product would change. Maybe the feedstocks or the raw materials would change. The composition would slightly vary. That will impact the product. So your process should handle those changes. Then once you have the construction of that project, then it will lead to the commissioning. Now, what happens in the commissioning, that every piece of equipment that we install in the plant, it has to be tested, and it has to be approved by the company and the vendor itself. Okay, so it has, like, everything should be rechecked and see if it is operational or not, or it is matching with the specification or not. Okay, so at the commissioning stage, we verify each of the equipment and how it is operating. Then it will lead to the startup. So the startup will give you the actual production of the products from the raw materials, and then it will lead to the normal operation. Now let's see what we have. A design is an evolutionary process, and we start with the input and the output diagram. Then we will make the generic diagram. Then we will make the block flow diagram that will lead to the process flow diagram, and ultimately we can have the P and ID. Okay, so this one is a process of evolution that we can have when we are going to make any industry, or we are going to make any chemical process. Okay, so it will start with the minimum information. What is input and output diagram? It is a crude block flow diagram in which only feed and product streams are identified. Okay, so input and output is here, and you don't have any information, and based on the cost of the feedstocks and the produced chemicals, we will just analyze and see if the project is feasible or not. If we see some feasibility at this part, then we will move to the generic diagram. Now, what is the generic diagram? It will contain some more information compared to the input and output diagram. It breaks the process into basic elements such as reaction, separation, and recycle sections. Okay, so the main process units that may include the reactors, then the separators, and the recycles. Okay, so this generic diagram, it is slightly more advanced compared to the input and the output diagram. Then once we have this diagram, then we will move to the block flow diagram. Now, block flow diagram includes the material balance calculation. Now you see that as you're moving downward, the information level is going to increase. Now in the block flow diagram, we have to provide the material balance calculations. Now when we move to the PFD, process flow diagram, then we have to provide the complete mass and the energy balance and the preliminary equipment specification. Okay, for example, in the PFD, you will see the actual units in their actual form. You have to provide the mass and the energy balance, and what are the equipment specifications. Okay, what should be the inlet and the outlet temperature, pressure, conversion, and these kinds of things. Okay, now the last part is the P and ID, that will include the piping and instrumentation diagram. Now it will give you the mechanical and instrumentation design, how those equipments can be integrated with one another. Obviously, we have to use the pipelines, right? So what is the distance of one unit from the other unit, and which pipeline can be used, and what should be the diameter and the length of the pipeline, and if there is any additional pumping required in that pipeline, and what kind of instrumentation that we need to have to run that process. Okay, so this is the most advanced form of the process diagram. Now, here we have the comparison between the BFD, PFD, and P and ID. So with the least information, we can draw the BFD, but as we are moving towards the P and ID, the level of complexity and the information, it will be increased. Okay. Now, if if you're moving toward from P and ID towards the PFD, it will increase the level of the conceptual understanding. Okay, so when you don't have anything, then you make the BFD, which is at the conceptual stage, and then we keep on adding the details, which will make the process more complicated, and it will give you the P and ID. Now, BFD shows all processing picture of the chemical complex. It will include flow of the raw materials and products may be included on the BFT. So BFT will contain the mass flow rate information about the feedstocks and the reactants and the products. BFT is a superficial view of the facility. CHE information is missing. Okay, so it will give you just the generic overview of the facility, what should be the main units, and what should be the input and what should be the output. It will not include any of the engineering design. Okay, it is useful as an orientation tool. Okay, so if you just want to give a very quick overview of a process, we usually use the BFT. Okay, then used to sketch out and screen potential process alternatives. As you know that for making any of the product, there could be different routes that can be used to get the same product. So block flow diagrams can be used to develop or to represent different process alternatives. And if the block flow diagrams shows represent some good alternatives, then the process flow diagram and the P&IDs can be developed for that process and see the detailed feasibility of the project. Now, definitions of the BFD. BFD block flow diagram. You should have an information about the starting point for developing BFD. It will provide you the starting point for the process flow diagram. Helpful in conceptualizing new processes. So whenever you're making some new process, then uh, making a BFD can be a good start. Similar to sketches in material and energy balances. So we have seen some examples in CHE21 and CHE202 courses, and that will simply include the blocks which are connected together. So that gives you a sense of the BFD. Okay. Now there is a figure one I will show you here. Which one? This one is basically the production of the benzene from toluene and hydrogen. Now here you can see that there is one reactor, one separator, and one distillation column. So we are having three main processes here, and we can represent each of the process here with simply plot, in which we show them the input stream, output stream. If there is any recycle like this one, if there is any recycle, we can show that one, and we can simply give the information about the flow rates and the conversion. Okay, so this is the reaction. The toluene is getting reacted with the hydrogen to give you benzene and the methane. Okay, so this is a simple block flow diagram of for producing benzene from toluene and hydrogen. Okay, now block flow diagram, it gives you a general view of the large complex plant. It will block flow diagrams like here, it will give you the overall idea which things are being reacted, with what things are being separated, and if there is any requirement of the recycle. Limited information is provided. Now you can see here only very least information is there. You should only the information about the flow rates is given here. Okay, we don't have any information about the purity. We don't have any information about the units that are being used. Okay, and what are the technical aspects of each of these units. Okay, so this is basically the block flow diagram, and it is the simplest diagram that we make at the conceptual level. Now this is the one diagram for producing benzene. Now let's see another block flow diagram of producing higher alcohols from the coal. Now you see it will the process start with the coal preparation here, then there is a gasification, then in gas recovery unit there could be some gas turbines, steam turbines. Okay, a separation unit, some acid gas removal units, and then closed process for the sulfur separation. Okay, now by making the block flow diagram of this process is this kind of process, it is much easier for everybody to understand what is happening at each of the process. Okay, with the very least information. Maybe we can also add the information about the flow rates, but that will make this one more complex. So whenever you make any process and you want to represent that process to the general audience, then we make the block flow diagram with the minimum information to show what is the input and what is an output. Now let's see what are the conventions and the formats for the block flow diagram. Operations shown by block. Okay, so the first thing that you see here, the operations that are being taken place here, these are represented by the blocks. Major flow lines shows with the arrows. Okay, now here you can see the major like the connection lines. These are shown by the arrows. Okay, flow lines from left to right whenever possible. So whenever you make the block flow diagram, the process will start from the left like here, and the products you will see on the right hand side. So this is the general convention. Light streams towards top with heavy stream towards the bottom. Okay, so the streams, for example, what is meant by the light stream? Maybe if some gases are being separated from the liquid, so the gases will go at the top and the liquid will go at the bottom. For example, in this resistical process where we can separate the carbon dioxide and the H2S in the gaseous form, so we see that these gases are coming from the top of this block, whereas the liquid stream, which is the water, it is going to be at the bottom side. Okay, critical information unique to the process is supplied. So for each of the unit, you have to simply provide the critical information. In the critical information, you can write down the temperature and the pressure for all of these streams. Okay, and if there is any specified conversion for any of the process, for example, you're using some reactor, so you can specify the conversion of the reactants taking place in that reactor. Okay, if lines cross, then horizontal lines is continuous. Okay, so you see the streams here where different streams are like interacting with each other. Okay, so if there is a horizontal line, it will remain as such, but if there is a vertical line being connected within different processes, so it should be like in this way in which you show no line. Okay, so the horizontal lines should be continued, but the vertical lines, they cannot be continued during the intersection. Simplified material balance is provided. Okay, so whenever you make the block flow diagram like this one, you can simply provide the material balance. Okay, obviously it will not give you the material balance of each of the stream in a very detailed way, but it will just give you the material balance in a generic form. Okay, for example, in this stream benzene, there could be some mixing of the toluene or the hydrogen in small quantities, but we don't show that. So we will only provide the